Hello, everyone. Welcome to our very, very short presentation on automated root cause analysis, neural network assisted, or to put it shortly, Arcanna. Assuming my clicker will work, great. My name is Bogdan Sas. I'm a principal solution architect for Siscale, and I'm an infrastructure guy. I work with computer networks, I work with servers. Lately, I've been focusing on data center technologies. That means compute, storage, networking, and so on. I have seen the evolution from physical servers to virtual machines, lately to containers. And I have seen one very important problem that arises with this evolution. We begin to lose visibility. We begin to no longer see everything that is happening in the network. And this can make root cause analysis, this can make identifying issues very, very difficult. How do we do root cause analysis the traditional way? What happens when we have an issue? Generally, all we know is something isn't working or something is slow. What do we know? What happens? Alerts go off. The application team gets an alert. They say, nope, it's the network. It comes to the network guys. Can you guess what happens? It's not us. It's the server guys. And then the server guys say, it's not us. It's the app. And we spend a lot of time just going back and forth, just trying to figure out where the actual problem is. How long does this take? Well, I'm sure you already know. It can literally take hours before we even know where the problem is, before we even know who we need to talk to in order to go ahead and start fixing the issue. Why? Because we are still looking for the same needle inside the same haystack, but the haystack just keeps becoming larger and more complicated. OK, we do have a solution, and this already exists. We have a way to gain better visibility into our infrastructure. We have Elasticsearch and the Elastic Stack that allow us to actually see everything that is going on. And one thing that is great about Elastic is that it allows us to get both time series data, metrics, and also we can get the logs and see what is happening. OK, let's add Elastic to the mix. This is a demo from the people at Elastic. You can find the full demo here on YouTube. It's simply troubleshooting a problem that occurred in an application. The application is slow. That's all we know. How do you go in order to investigate this? Where do you go? What do you need to see? Well, first of all, we start with a problem. This is the Elastic Stack machine learning, unsupervised machine learning. It tells us something has deviated from normal. The response time is much higher than it usually is. OK. We go in, we can see the graphs. We see that we have a problem, something that has a very clear start and stop. We can see that we look at the trace. We can look at everything that makes up the actual web request. No smoking gun. We still cannot pinpoint the issue. When the application is slow, all the requests are slow. OK. We move on. We switch. We have full visibility. We go to another place. We look at the infrastructure. We look at the actual containers making up the application. And something begins to be visible. There is one container. It happens to be the database container that seems to be acting up. We dig deeper. We look at the CPU. And we see that we have some spikes on the CPU, some periodic spikes. We look at the processes. There is a backup running that every 4 hours makes everything grind to a halt. We switch once again, we go to the logs, and we actually see the slow query log. We see what is happening and why the issue was there. This is here. This is possible. The Elastic Stack is great for doing this, but it's not the only tool that does this. It's possible. We can do it. How long does it take? How long does it take you to actually go through all of these interfaces to actually figure out where the problem is? Well, the answer is it depends. Depends on the infrastructure, depends on how large it is, depends on how complex it is, and depends on how well hidden the problem is. The problem with visibility is that sometimes we begin to have too much information. Sometimes there is such a thing as too much visibility. There's too much information. It's very difficult for human beings to keep track of everything. It's very difficult to go through all of these logs. Anybody ever tried going through logs by hand to see where the problem was? It's very, very difficult. We need help. We need assistance. And this is something that a machine can do really, really well. So what happens? Let's talk about Arcanna. Let's talk about what we are adding into this mix. This is what we already have. We have the events. They're going into the Elastic Stack. Everything is there. We have full visibility into our infrastructure. What happens next? We have event clustering. We have an algorithm that can decide whether 2 or 10 or 15 or 50 alerts are part of the same issue. We alert only once on them. We have the possibility of identifying what the actual root cause was. And once we have these two, we can actually go ahead and only alert the correct teams. Is it a database problem? We go to the database team. A server is acting up, we go to the server's team. We have a power failure in the data center, we go to the right team to fix that. OK, what do we do next? What do we do once the problem has been resolved? This is the most important part. We provide feedback. This is supervised machine learning. And I will show you the architecture in just a second, but this is important. This algorithm will actually learn. When you had an incident, it tells you, I think the root cause was the database server. You go back and you tell it, yes, you're right, that is correct, reinforce what you already know. Or we go back and tell it, no, this time it was the mail server. And the algorithm continually learns and it continually adapts to your infrastructure. This is the architecture. The actual machine learning happens here. This is a separate unit. This is using TensorFlow. I'm sure everybody here already knows about TensorFlow. It's big in the machine learning world. This is the component that actually extracts the data from Elastic. It runs machine learning on it. It provides a probable root cause. And it actually sends this information back into Elastic. So it's available from any other tool that you might have that reads data from Elastic. You have your own dashboards. You will be able to see this information as part of your dashboards. OK, the question here is, how do we actually interact with it? This is why we have the second part. This is a Kibana plugin that simply allows us to interact with this tool. You go in, you create the machine jobs, and I will show you the workflow in just a few seconds. And once the jobs are done, you use the same plugin to actually provide feedback to the machine learning algorithm. This is the flow of data. Again, what we have here already exists. If you are using Elasticsearch in any way to monitor your infrastructure, this is already in place. This is what we have added. We have data being pulled into the machine learning engine. behind Arcanna. And once analysis is complete and once we provide feedback to the machine, all of this information goes back into Elasticsearch indices. So all your data is still in the same place. All your data is still available to use with any tool you are using now in order to view it. What happens next? So this is the present. This is what we already have. What about the future? Once we have this data, once we have a machine that can predict with enough confidence the root cause of an incident, imagine this. This is the next step. We're not there yet, but I think you will agree that this is interesting. Imagine actually triggering an automated response, having an Ansible playbook that runs on your servers and corrects the issue before your customers have time to notice, before you are woken up at 3 a.m. by your pager going off, or whatever, SMS, any kind of alerts. Once we know the root cause, we can actually take action to fix the issue. So, OK, the theory is nice. What does this look like in practice? This is the interface. Does it look familiar? It should. It's not different from everything you have been using so far with the Elastic Stack. It's Kibana. It's just one plugin, running on top of Kibana. You create the job, you tell it what indices to use, and from those indices, you tell it exactly what fields to take into consideration when actually running the algorithm. You can actually remap some of the fields so that you have a coherent structure in order to allow the machine learning algorithm to work. And once you have done all of this, the machine starts learning. And it begins to see the events and analyze them. Once something has gone wrong, this is the output. What alerts did I have? I had issues A, B, and C. Are they related? Yes, they are part of the same problem. What was the root cause? What actually triggered everything? Well, a server was out of memory. I only alert the team responsible for that particular server. Is this enough? Is this where the story ends? No, because remember, there is one more very important part. We still need to provide the feedback. And these are actually changeable. You go in and you tell the system, yes, this was the root cause. Yes, you are right, this was the actual cause of the problem. Or you say, no, that was just a symptom. The root cause was something else. And the system will learn, the system will adapt, and it will take this into consideration for the future. The more you use the system, the more it adapts to your exact network, and the better it will be at actually predicting what happens in the future, what the cause of an issue is. OK. So to summarize, this is what we already have. With Arcanna, we have, so let me go back for 1 second. Remember, we already have machine learning in the Elastic Stack. This is what we have here. That is unsupervised machine learning. It learns from what the normal behavior is. It alerts us when something deviates from the norm. What we are adding here is supervised machine learning. We are actually providing feedback. We have a system that adapts to changes, that adapts and learns from previous decisions. And from here, we go to alerting only the correct teams, and we go to, maybe in the future, actually going to automated remediation of issues. This is Arcanna. This is what we are adding to the Elastic Stack. Now, where can you go to see this happening live? You can talk to my colleagues at our booth. You can actually see this happening, but I have even better news for you. This will be open source. We will be releasing this as open source, probably next week, but I will have to check with my colleagues for the exact date. But you will be able to actually take this, install this in your network, play around with it, see if it works with your existing infrastructure. So this will be completely open source. You can just go ahead and install it. OK, so thank you. If you have any questions, now is the time to let me know. Remember, I'm the infrastructure guy. If you have any questions about the code behind Arcanna, if you have any questions about the actual machine learning, I have my colleagues here who have actually developed the software that can help you with answers. If there are no questions, then thank you very much. I hope this was interesting, and I hope that you will give it a try once it has been released. Thank you.